Let's take a look at volume the disk method. Get my recorders going here. There we go. And there we go. Okay, volume the disk method. This revolves around revolves. This indicates taking a two-dimensional shape and revolving it around something. And for this one, see I'm revolving around the y-axis, and see the shape it creates. Now it looks like it's hollow, but it's not supposed to be hollow. And we get that shape. Let's look at another one. There we go. The idea is to find out the volume of that region. So you could have water in it, you could have metal in it. Just trying to find the volume of it. Take a look at this one. Sometimes the shape you get is just like pretty strange compared to the beginning, like that right there. Look at the base of it. It's a circular base. Started out as a triangle. So that's how we can get that shape. And I think this is the last one. This looks like it's revolving around the x-axis. My eyes aren't. I'm having trouble seeing that. Yeah, it's around the x-axis. Like that. Okay. Well, here's our formulas. Now this is the disk method. This is when you're given one function, and you're revolving it about the x-axis. The function must be of the form y equals, and a and b are in terms of x values. So revolving around the x-axis, these have to be x values. And specifically, these have to be in terms of x in here. Like y is equal to 3x minus 1. You'd have 3x minus 1 in here. So, and then dx. So everything's x's. Disk method around the y-axis. C and D are y values. This r of y must be of the form x equals, which means these have to have y's in here. So you'd have like x is equal to 5y minus 1. So 5y minus 1. And this is y. So everything's y's. Now the washer method, that's where you got two functions, and we'll see. I think we got some pictures of that. But this is your outer, the capital R of x, and the little r of x is your inner. If it's over on the right side, the outer is your one furthest to the right. So, but I mean, it doesn't have to be on the right side. Though it seems like a lot of them they do set up that way just so you can see it. Function must be of the form y equals. Well, again, a and b are in x values. This is dx. Everything has to be x's. And then this one, c and d are y's. Everything has to be in terms of y's. This is around the y-axis. Now, if you're using the washer method revolving about a line, then your r of x, capital R of x, is your line minus your graph furthest out. That's your outer. Your little r of x is the line minus the nearest graph. So let's take a look at these and solving some problems. Let me see. We got y is equal to 8 minus x to the third, and want to revolve it around the x-axis. Well, around the x-axis, we're going to look at our x values. So volume. I think it was pi out in front, a, b, and r of x squared dx. I'm going to go double check that. My memory is not what it should be. Okay. About the x-axis, a, b, r of x. Yep, that's correct. Now specifically, everything has to be in terms of x's. So we got our pi here, and x values, if I look at it, looks like from 0 to 2. And then r of x squared, well, r of x is going to be 8 minus x to the third squared, and dx. Okay, so pi stays out in front. When I square this, I'm going to take 8 minus x to the third times 8 minus x to the third dx. Which gives us 8 times 8 is 64. 8 times negative x to the third is negative 8x to the third. Negative x to the third times 8 is negative 8x to the third. And negative x to the third times negative x to the third gives us a positive x to the 6. You add the exponents. Dx. Which gives us x to the 6 minus 16x to the third, combined together like terms. The negative 8x to the third, negative 8x to the third gives us negative 16x to the third. And then plus 64 dx. Okay. Add 1 to our power, divide by our new power. So we got 1/7 x to the 7th. Add 1 to our power, divide by our new power. So minus 16 fourths x to the 4th. And then 64 becomes 64x. I'll plug 2 in. So we got 1/7 times 2 to the 7th minus 16 divided by 4 is 4. 2 to the 4th plus 64 times 2 minus, and we've got pi times all of this. Then 1/7 0 to the 7th minus 4 0 to the 4th plus 64 times 0. That last part just gives us a big 0. So we're just going to deal with this first part. So I got pi times 2, 4, 8, 16, 32, 64, 128. So 128 over 7 minus 2, 4, 8, 16 times that. 16 times 4 is 64. Yeah, 64. And 64 times 2 is 128. So we got 128 over 7 plus 64. This is a mixed number, so I'm going to take 64 times 7. Gives us 448. Then I'll add to 128. 6, 1, 7, 576. So 576 over 7 pi. I don't see where it simplifies. 56, nah. So this would be your answer. That particular problem. So let me save this. What's this called? This is called volume the disk method. let's see, volume, the disk, method, page 01. There we go. And let's look at our second problem. So we got y is equal to 4, and y is equal to 8 minus x squared. Now, this is going to be formed by a revolving region around the x-axis. Notice how there's a gap right in here. So if I revolve that around, look like a flat donut, standing up, a standing up flat donut. Okay, so around the x-axis. I don't think I really remember the formula. I think it's r of x squared minus little r of x squared, but let me see. Yep, yeah it is. Okay. So I got pi, and then a to b, and then r of x squared minus little r of x squared dx. Let's see if I got it right. Yep. Well, I'm revolving around the x-axis. The graph that's furthest away is this one. So this is our outer one. That's our capital R of x, the 8 minus x squared. And this little one closest to it is our inner, which is our a little r of x, which is 4. So a to b, well, from -2 to 2. So it looks like. Now, if I'm not quite sure about that, I could set these equal to each other and solve it. Remember our POIs. The reason why they give you these graphs, though, is so you don't have to go that much work. But 4 is equal to 8 minus x squared. Take negative x squared to the left side, becomes a positive x squared. 8 minus 4. We get x squared is equal to 4, and x is equal to plus or minus square root of 4, or x is equal to plus or minus 2. So it is from -2 to 2. And then we want our outer one, which was the 8 minus x squared. That's squared. Minus our inner one, which was 4 squared and dx. So let's find this now. So we got -2 to 2. We got 8 minus x squared times 8 minus x squared minus 4 squared is 16 dx. By the way, I'm not going to do it, but you know some symmetry here, how this piece on this side is symmetric to this. It's even. You could use that fact if you wanted to. Okay, so 8 times 8 is 64. 8 times negative x squared is negative 8x squared. Negative x squared times 8 is negative 8x squared. And negative x squared times negative x squared gives us x to the 4th. Minus 16. Okay, and then we got x to the 4th first. Negative 8x squared gives us negative 16x squared. 64 minus 16 gives us 48 dx. Okay. Add 1 to our power, divide by our new power. So we got 1/5 x to the 5th minus add 1 to our power, divide by our new power. So minus 16 over 3 x to the 3rd plus 48x. And then we'll plug in our values. So we'll plug in 2. So we've got 1/5 times 2 to the 4th minus 16 thirds times 2 to the 3rd plus 48 times 2 minus, and then we'll plug in negative 2. So we got 1/5 times negative 2 to the 4th minus 16 thirds times negative 2 to the 3rd plus 48 times negative 2. Okay. 2 to the 4th is 16, so that gives us 16/5. Minus 2 to the 3rd is 8 times 16 for 128. So 128 thirds. 16 times 8, 8 for... Yeah, that's right. And 48 times 2 is 96. Minus negative 2 to the 4th is 16/5. Negative 2 to the 3rd is negative 8. Times 16 gives us a positive 128 over 3. And 48 times negative 2 gives us negative 96. Okay. Now I got 16/5 minus 128 over 3 plus 96. Negative out in front of this bracket flips sign of everything inside. So it becomes a negative 16/5 minus 128 over 3 plus 96. Now the 16/5 minus 16/5 drops away. Negative 128 over 3 and negative 128 over 3 is negative 256 over 3. 96 plus 96 is 192. 2, 1, 10, 192. Okay. Now this is a mixed number. We'll take 192 times 3. Gives us that, and then subtract 256. And we end up with, what do we end up with? Positive, I guess. 320 over 3. So our answer is 320 pi over 3. Assuming I didn't make a simple math error, which is very easy to do on these. Okay, let's look at next problem. Okay, set up and evaluate the integral that gives the volume of the solid formed by revolving region about the y-axis. Okay. So we got y is equal to 3, and y is equal to x to the 3rd. About the y-axis, you have pi out in front still. This goes from, I think I use C and D. Not that it matters what letter. And then r of y squared dy. Now let me go double check that. There it is. C and D, r of y squared dy. Okay. And that's about the y-axis. Okay, so y is equal to 3, y is equal to x to the 3rd. There's a problem with this. About the y-axis, this r of y function must be of the form x equals. So we have to have like y is over here. C and D are in terms of y values. That's easy. So this looks like it goes from 0 to 3. Like that. And now find r of y. Well, we got y is equal to x to the third. And we want to solve for x. So I take the cube root of both sides. And those are going to cancel and gives us x. So we got x is equal to y to the 1/3. So this would be y to the 1/3 squared dy. So that's our setup. So we got pi, and then that doesn't change. And then when I raise an exponent to another exponent, I multiply them together. So that gives me y to the 2/3 dy. Now I'm going to add 1 to my power, divide by my new power. So when I add 1 to this, that's like 3 over 3. So I get y to the 5/3 over 5/3. If you got a fraction down below, you can flip it and multiply times your top. So that gives us 3/5 y to the 5/3. Now, if you got a number inside here, you can always take it out in front. So you take the coefficient, put it out in front. And then we got y to the 5/3, 3, 0. So let's plug that in now. So we got 3/5 pi times 3 to the 5/3 minus 0 to the 5/3. Well, 0 to any power is 0, so that drops away. And this right here would be 3 to the 5/3. Probably easiest. I don't think it wants to put it back in radical form, but maybe. This is 3 to the first, so I'm taking 3 to the first times 3 to the 5/3. I'm going to add the exponents, so that gives us 1 plus 5/3 gives us 8/3 over 5 pi. I definitely could put this back into radical form, but that's our answer. Now remember, you can check these, like up here, assuming you got the setup correctly on your calculator. If I come here, do a clear, do my X key, caret, doesn't matter what variable you put in, same idea. And then beginning parentheses, 2 divided by 3. Closing parentheses. And then we'll do second trace, and choose the last one, our integral. And then we're wanting it from 0 to 3. So for the lower limit, I put 0 in, enter, and then 3, enter. And we get 3.744. Question is whether this is the same as 3.744. So we do a second mode to exit out. I'll do 3 caret, beginning parentheses, 8 divided by 3. Whenever you have more than a single number or a single x in your exponent, you have to put parentheses around it. Divide by 5 times pi. So second caret. And that's different than what we got, isn't it? Let me go check my stuff. Okay, raising it to oh. Did I do 2/3? Yeah, I did. Oh, times pi. Okay, so times pi. No, I already did that. Never mind. So why did I get a different result? Let me check my work. I'm sure I screwed up somewhere here. Okay, 2/3, add 1 to your power, 3 over 3. Okay, then flip that, and we'll put it out in front, that's correct. Take 3/5, put it out there, that's fine. And then put the 3 in there. 3 to the first times, so we add the exponents. 1 times 3 is 3. 8/3 divided by 5 pi. Three caret 8 divided by 3 divided by 5 times pi. Oh, this doesn't have pi involved with it. If I bring pi in, there, now let me do it. So second trace, and choose that. What is A, from 0 to 3? Yeah. So 0, inner, 3, inner. 11.76. Okay. When you use a calculator, you have to bring this pi on the inside. Otherwise, you won't get the same value. But anyway, that's how you do it. I knew it. I felt real good about doing it by hand. But you never know. It's so easy to make a math error. Add numbers wrong, multiply them, so forth. So let me save that. And let's look at the next problem. Okay. Set up and evaluate the integral that gives the volume of the solid formed by revolving region about the y-axis. Well, it's solved for x, so that's perfect. That's what we want. And let me write the formula down that we're going to be using. It's number 4. Volume is equal to pi, and I think I use C's and D's. And then we're going to have our r of y squared minus our little r of y squared, dy. These are going to be y values, and these have to be in form of, have y's in them. Okay, so for our y's, this is going to go from 0 to 2. And then our outer one is the one furthest away from the, we're revolving around the y-axis. So the outer one's this line right here, which is x equals y plus 3. So we'll put in y plus 3 squared there, minus. And then our inner one is this x equals 2. So we'll have 2 squared dy. You'll know if you did it wrong if you get like a negative volume instead of a positive. That's one indicator. Okay, so we're going from 0 to 2, and we got y plus 3 times y plus 3 minus 4 dy. Y plus 3 times y plus 3. Y times y is y squared. Y times 3 is 3y. 3 times y is 3y. 3 times 3 is 9. Minus 4 dy. So we got y squared. 3y plus 3y is 6y. 9 minus 4 is 5 dy. Pi out in front, add 1 to our power, divide by our new power, so we got 1/3 y to the third, plus, add 1 to our power, divide by our new power, 6/2 y squared, plus 5y. Now the 0 isn't going to add anything, so we can drop that. So we plug in the 2, we got 1/3, 2 to the third, plus 6 over 2 is 3, times 2 squared plus 5 times 2. Again, this would be minus, and if I put 0 in here, 0 in here, and 0 in here, it's just going to be a big 0 over there. Well, 2 to the third is 8, times 1/3 gives us 8/3. 2 squared is 4, times 3 is 12, 5 times 2 is 10, which gives us 8/3 plus 22. 22 times, this is a mixed number, 22 times 3 is 66, and add the 8, and we get something, 74. So we got, the answer is 74 pi over 3. And let me save that. Let's look at our next problem. It says, find the volumes of the solids generated by revolving regions bounded by the graphs of the equations about the given lines. Okay. So we got y is equal to the cube root of x. We got y is equal to 0. And x is equal to 8. And the first one says about the x-axis. Well, about the x-axis, our formula was volume is equal to pi a to b, and y is equal to the cube root of x. That looks like that right there, more or less. And we said y is equal to 0. Y is equal to 0 is this line. And x is equal to 8. So there's x equals 8. Okay. Revolving around the x-axis. Well, this is the disk method. There's no in between. We're just bounding this graph by the x-axis. And let me see. So this is going to be r of x squared dx. So this is going to be from 0 to 8, and our graph, cube root of x squared dx. Okay, so let's find that. So 0 to 8, and cube root of x is x to the 1/3, raised to the second power dx, which gives us x to the 2/3. You raise in one exponent to another exponent. Add 1 to our power, divide by our new power. So we got 2/3 plus 1, which gives us 5/3. So we got x to the 5/3 over, divide by your new power. Take that fraction, flip it, and actually I'm going to go ahead and put it out in front. So we got 3/5 pi and x to the 5/3 right there. Now if I put 0 in here, 0 to any power is 0, so I don't need to worry about that one. I just do the 8. So I got 3/5 pi times 8 to the 5/3. Gives me 3/5 pi times 8 to the 1/3 to the 5th power, which gives me 3/5 pi times the cube root of 8 to the 5th power, which gives me 3/5 pi, cube root of 8 is 2, so times 2 to the 5th, 2, 4, 8, 16, 32. So we got 32 times 3, which gives us 96 pi over 5. There we go. Okay, so B. Now y is equal to the cube root of x. Y is equal to 0, and x is equal to 8. And our graph, again, is that right there. And y is equal to 0. Is this right here. And x is equal to 8. Would look like that. Well, we're wanting to revolve it around the y-axis now. And our volume for that is pi, and then CD, and then our r of y squared dy. So we have to solve this one for x to begin with. So we got y is equal to the cube root of x. Take both sides of the third power, so we got y to the third is equal to the cube root of x to the third power. You're raising a radical that has the index matches the power. Just gives you x. So we got x is equal to y to the third. And the question is, what are these values going to be? Obviously 0 is one of them, but how do I determine this? Well, if this is x equals 8 and this is x is equal to y to the third, then we can find our POIs. So I'll set the 8 equals y to the third, since they're both x equals. Then take the cube root of both sides, and we end up with y, and the cube root of 8 is 2, so y is equal to 2. So it is from 0 to 2. That's what it'll look like, but pi's out in front, 0 to 2, and then we got the y to the third to the second power dy. So let's do this one. Well, y to the third raised to the second power gives us y to the 6 dy. Add 1 to our power, divide by our new power, so we got 1/7 y to the 7th, 2 to 0. Now putting 0 in doesn't do anything, so I don't need to worry about that. We'll just plug the 2 in. So I got 1/7 times 2 to the 7th. 2, 4, 8, 16, 32, 64, 128 over 7. So 128 pi over 7. Now notice, this is 96 pi over 5, and this is different. They're not meant to be the same. We're not finding the area just as what's bounded by these graphs. We're finding when it revolves around. If we revolve it around a different axis, the graph will look, the volume will be different. So, okay, part C. The line x is equal to 8. And let me write all that down again. X equals 8. Now, revolving around a line x is equal to 8. We've been revolving around the line x is equal to 0. X is equal to 0 is the y-axis. So keep that in mind. Remember, this is the same as x is equal to y to the third. Let's look at our graph. So we're going to be taking this piece right here, and we're going to revolve it around this line, x is equal to 8. So it's going to be revolving around the same idea as the y-axis. So when we set this up, we got pi, and think of what these values would be. They're the same as what we did here, right? 0 to 2, our y values. And over here, there is no r of x and little of x because there's just one graph here we're revolving around at. But if we did put that in there, our line minus our farthest graph. Well, if we did, which one's our farthest graph? Okay, this one right here. Okay, let me, r of y squared minus little r of y squared dy. So we got 0 to 2. Now this one right here, line minus the farthest graph. So we got 8 minus our farthest graph, which would be this one right here. So we got, what is that? The y to the third squared minus, and then the little r of y. This is one that's throwing me, is sitting there making me pause. We got our line, which we're revolving around 8, minus the nearest graph. Well, the nearest graph is this one right here that's sitting right on top of it, which is 8 squared and dy. I'm about out of space. So then this gives us, when I square that, that gives us y to the 6 minus 16 y to the third plus 64 dy. And let me write that down because I'll have to continue on another piece of paper. Or not a piece of paper, I mean another electronic piece of paper. There we go. So let me save this. Long problem. Okay, so we're still on C, and we're now down to volume is equal to pi 0 to 2 of y to the 6 minus 16 y to the third plus 64 dy. Okay, add 1 to our power, divide by our new power. So we got 1/7 y to the 7th minus, add 1 to our power, divide by our new power, minus 16/4 y to the 4th plus 64x, excuse me. Now the 0 we don't need to worry about. So plug 2 in. So I got 1/7, 2 to the 7th, minus 4 times 16 over 4 is 4, times 2 to the 4th, plus 64 times 2. 2, 4, 8, 16, 32, 64, 128 over 7. Minus 2, 4, 8, 16 times 4 is 64. Plus 128. Which gives us 128 over 7 plus 64. Take 64 times 7. 8, 2, 42, 448. 128, 617, 576 pi over 7, if I didn't make a math error. 64 times 7, 8, 2, 44, 448 plus 128, 16, 1, 7, 5. that looks right. Okay. D. About the line x equals 10. So again, it's revolving around the line x equals 10. That's like revolving around the y-axis, the y in that, well, not y-axis, but around that direction. So we're going to be working with I wonder what the hand does. Move picture. X is equal y to the third, and y is equal to 0, and x is equal to 8. And it's still 0 to 2. That hasn't changed. Now, this is the part that always makes me pause. Okay. So here's our graph. And here's 8. It's like that. And we want to revolve it around 10. So around this line. Okay, so 0 to 2. And we got our line, which is 10, minus our outer one, this one, y to the third, squared, minus, then our line minus the one closest, which is 8, squared, dy. Well, when I square this, I get 10 minus y to the third times 10 minus y to the third, minus 10 minus 8 is 2, so we got 2 squared, dy. Let's see, pi 0 to 2. 10 times 10 is 100. 10 times negative y to the third is negative 10 y to the third. Negative 10 y to the third. And negative y to the third times negative y to the third is y to the 6. Minus 4 dy. Which gives us y to the 6. Negative 10 y to the third. Negative 10 y to the third is negative 20 y to the third. 100 minus 4 is 96 dy. Okay, add 1 to our power, divide by our new power, so y to the 6th becomes 1/7 y to the 7th, minus, add 1 to our power, divide by our new power, so minus 20 over 4 y to the 4th, plus 96y. We don't need to plug 0 in, that's not going to do anything, so I just plug the 2 in. So we got 1/7 times 2 to the 7th, minus 20 divided by 4 is 5, times 2 to the 4th, plus 96 times 2. 2, 4, 8, 2, 4, 8, 16, 32, 64, 128 over 7. Minus 2, 4, 8, 16 times 5, 80. Plus 192. Um, 112. Okay, mixed number. I'm going to take 112 times 7 and add 128. And assuming I didn't add something correctly or multiply something, or didn't add or multiply incorrectly, our answer is 912 pi over 7. And let's save that. We're done with that problem. Finally. It's a long problem. Okay, let's go to the next problem. over 6. Okay, so we got y is equal to 2x plus 1. Y is equal to 4. And x is equal to 0. So y is equal to 2x plus 1. Like that. Y is equal to 4. Look like this. X is equal to 0 would be the this right here. So our area we're talking about is this right here. And we're wanting to revolve it around the line y is equal to 6. So here's the one I'm going to revolve it around. So I'm going to be revolving it around this. That's the same direction as revolving it around our x-axis. So go look at our formula for that. See how everything A and B are in terms of x values? Everything has to be in terms of the x values. Now specifically, this is what we got to look at, because this is the washer method. So we got pi, and obviously this is going from 0 to something. This something right here is the intersection of y is equal to 4 and y is equal to 2x plus 1. So for our POI, we said 2x plus 1 is equal to 4. Take the 1 over, and we got 2x is equal to 3, or x is equal to 3/2. I guess that might seem reasonable. 1.5. Okay. So this is going to go from 0 to 3/2, like that. And r of x is line minus the furthest graph. Well, our line was, what is our line? Y is equal to 6. So we're going to have 6 minus our farthest graph away from that, which would be this one right here. So minus 2x plus 1 squared, minus, and then our line minus our nearest graph, which would be this one right here, which is y is equal to 4. So I'd have 4 there, squared, and not dy, dx. Okay, let's find this one. So I got 6 minus 2x. My eyes got off. Okay, there we go. That negative is going to flip sign everything, so it becomes a negative 2x minus 1 squared minus 6 minus 4 is 2, so 2 squared dx. Okay, so that's going to be from 0 to 3/2, and we got negative 2x, 6 minus 1 is 5, squared, minus 4 dx. So I got negative 2x plus 5 times negative 2x plus 5 minus 4 dx. Negative 2x times negative 2x gives us positive 4x squared. Negative 2x times 5 is negative 10x. 5 times negative 2x is negative 10x. 5 times 5 is 25. Minus 4 dx. So we got 4x squared. Negative 10x is negative 20x. 25 minus 4 is 21. Add 1 to your power, divide by your new power. So I got 4 to the third, or 4/3 x to the third, minus 20 over 2 x squared plus 21x, 3/2. Now that 0 drops away. It's not going to amount to anything if I were to plug it in. So I'm just going to plug in 3/2. So I got 4/3 times 3/2 to the third minus 20 over 2 is 10. 3/2 squared plus 21 times 3/2. And this gives us 4/3 times 3 to the third is 27, 2 to the third is 8, minus 10 times 9/4 plus 63/2. 3 and 27 both divisible by 3, that gives me 1, that gives me a 9. 4 and 8 both divisible by 4, that gives me a 1 there, it gives me a 2. So we're going to have 9/2 minus 4 and 10 both divisible by 4, or 2, sorry. 4 divided by 2 is 2, 10 divided by 2 is 5. So that's minus 45 over 2 plus 63 over 2. Um, 9 minus 45 gives us negative 36 over 2 plus 63 over 2. (63) minus 36 gives us 27 over 2. So our answer is 27 pi over 2. Save that. There we go. And let's take a look at our next problem. Okay, that was that one. So let's look at this one. We got x is equal to y squared plus 1, and x is equal to 3. And want about the line x is equal to 5. Well, let's graph this. Plus 1. So put 0 in for that. And I get 1. Okay. If I put 1 in, gets x equals 2. X is equal to y squared opens sideways like this. When you do a plus 1, I had to think whether it moves this way or back this way. I guess that makes sense going this way now that I've done it. And then x is equal to 3 would be this right here. Okay, and we want to revolve around x is equal to 5. So that right there. Okay, so this is going to be revolving around the vertical line there, which is like revolving around the y-axis. So let me look at my formulas about the y-axis. Okay, so everything's going to be in terms of y's. Okay, I just have to get this straight in my mind. So this looks good. That's in terms of y's. And let me shade to what we're going to be working with. This right here. We're going to revolve around that. Well, I have to find out what this point is and this point, because that's where we're going to revolve around. So that's the intersection of y squared plus 1 and x is equal to 3. So I'll set y squared plus 1 is equal to 3. Not sure what that green is. Ignore that. Take the 1 over, and we get y squared is equal to 2. So y is equal to plus or minus square root of 2. So this is going to be from negative square root of 2 to positive square root of 2. And again, I have to have this little cheat sheet in front of me here. Okay, so r of x is a line minus our farthest graph. The line is 5 minus our farthest graph is this one right here. That's farthest away from it, which is the y squared plus 1. And squared minus, and then our line minus our nearest one, which is 3. Squared and dy. Okay, so we got pi and negative square root of 2, square root of 2. 5, that negative there flips sign, so it becomes a negative y squared minus 1 squared minus 5 minus 3 is 2, so 2 squared dy. And got that. That gives us negative y squared. 5 minus 1 is 4. The second power minus 4 dy. When I square this, that gives me y to the 4th minus 8y squared plus 16. And then I'll bring the minus 4 down. Dy. And then from negative square root of 2 to square root of 2, we have y to the 4th minus 8y squared. 16 minus 4 is 12. Dy. Okay, add 1 to our power, divide by our new power. So we got 1/5 y to the 5th minus 8 thirds y to the 3rd plus 12y from negative square root of 2 to square root of 2. Now, you can look at this and you can see we have some kind of symmetry going on here. So instead of going from negative square root of 2 to positive square root of 2, I could go from 0 to square root of 2. And I'm going to do that on this one, save myself a little bit of work. Which means I would need to double my final volume. So I'll put a 2 out in front. And then this is going to go from 1... oops, let me write that down again. But it's going to go from 0 to square root of 2. Okay, now it doesn't do any good to plug the 0 in because that just drops away. So we just have to worry about square root of 2. So I got 1/5 square root of 2 to the 5th power minus 8 thirds square root of 2 to the 3rd power plus 12 square root of 2. Well, square root of 2 to the 5th power gives us 4 square root of 2. Square root of 2 times square root of 2 is 2, so that counts for 4 of those. I get that. Minus, and this is 8 thirds times 2 square root of 2, when you take the 3rd power, plus 12 square root of 2. It's probably easiest to just go ahead and factor out a square root of 2 and not worry about it. So we got 2 pi square root of 2, and that gives us 4/5 minus 16 thirds plus 12. which get a common denominator, 15. So multiply the bottom part by 3, this becomes 12. Minus, multiply the bottom part by 5, 0, 380. Plus, I'm just going to say 12. I'll handle that as a mixed number. So 2 square root of 2 pi. Subtract those, I get negative 68 over 15 plus 12. Take 12 times 15. And that gives us 180 and minus 68. 112, assuming I did my math correctly, which is always kind of iffy. So I got 112 over 15 times that. Oops, I'm about out of space. 2 times 112 gives us 224 square root of 2 pi over 15. So I didn't make a math error. That'd be your answer. Let me save that page. Let's look at the next problem. I think that was that one, wasn't it? Yeah. Okay, let's look at this one. We've got y is equal e to the negative x plus 2. X is equal to 0, y is equal to 0, x is equal to 3. And find the volume bounded by the graphs of the equation about the x-axis. What in the world does that look like? Okay, let's go graph it and see. Press y equals, press clear. We got e, so I do second ln, and then negative x, closing parentheses, and then plus 2, and then graph. Okay, so we got that, and then we got x equals 0, y is equal to 0. X is equal to 0 and y is equal to 0 is basically the x-axis and y-axis, and x is equal to 3. So it looks like that right there. And want to revolve it about the x-axis. So let's go look at our formula for the x-axis. Okay, nothing special here. This is just disk method. Washer method is because it creates a hole in the middle. So pi, and then this is our, everything's in terms of x's, yeah. So I'm going to go from 0 to 3. And then I'm going to take the e to the negative x plus 2 and square it, yeah, dx. So we're going to have e to the negative x plus 2 times e to the negative x plus 2 dx. E to the negative x times e to the negative x, you're going to add the exponents. Negative x plus negative x gives us negative 2x. E to the negative x times 2 gives us 2 e to the negative x. 2 times e to the negative x gives us 2e to the negative x. And 2 times 2 is 4. Been doing too many of these videos today. My brain's shutting down. I shouldn't start with the, or shouldn't end with the hardest one, I guess. So 0 to 3, and then e to the negative 2x plus 4e to the negative x plus 4 dx. And I'll split this up. 0 to 3 of e to the negative 2x dx plus 4 of e to the negative x dx plus 4 dx. Now this one, we let u equal to the exponent, negative 2x. du would be negative 2 dx. This one, our u would equal to negative x, so du would equal to negative dx. Okay, so all these are 0 to 3, so I'm going to put them back into a single one now. This one, I'm going to need negative 2 inside, so I'll offset it with a negative 1/2 out in front. So I'm going to have negative 1/2 e to the negative 2x plus 4. And here I need a negative inside, so I'll offset it with a negative out in front. So 4 times, negative 1, and then e to the negative x. And this one just becomes 4x. So let's plug in our values. So I have negative 1/2 e to the negative 2 times 3 minus 4 e to the negative 3 plus 4 times 3 minus negative 1/2 e to the negative 2 times 0 minus 4 e to the negative 0 plus 4 times 0. Okay, so this gives us negative 1/2 e to the negative 6 minus 4 over e to the third plus 12 minus negative 2 times 0 is 0. Anything to 0 power is 1, so that gives us negative 1/2. This gives us negative 4, and 4 times 0 drops away. This gives us negative 1 over 2e to the 6 minus 4e to the third plus 12 minus, and negative 4 times 2 is negative 8, and negative 1 is negative 9, so we got negative 9/2. It's got negative 1 over 2e to the 6 minus 4 over e to the third, 12 plus 9/2. This is negative 1 over 2e to the 6 minus 4e to the third. That's 12 times 2 is 24, plus 24 plus 9, 33. Yeah. I doubt they want us to get a common denominator here. Could. It would be 2e to the 6. This one already has that. This one, I would multiply the bottom part by 2 and e to the third, so that gives us 8e to the third. This one, I'd multiply the bottom part by e to the 6, so this gives us 33e to the 6. And so then I'd have 33e to the 6 minus 8e to the third minus 1 over 2e to the 6 pi. And that would be your answer. Assuming I didn't make a math error somewhere there. Last problem. Okay. Number 9. You got y is equal to cosine x, y is equal to 0, x is equal to 0, and x is equal to pi over 4. And oops, I'm thinking that wrong. Okay, let's try that again. Okay, so if I put 0 in here, I get cosine of 0, which is 1. But my first one would be pi over 2. And cosine of pi over 2 is 0, so it'll be down to there. So pi over 4 would be somewhere here. And then y is equal to 0 and x is equal to 0 is the axis. So this is our, oops, that's what we're working with right there. Okay. Find the volume about the x-axis. Okay, so about the x-axis, let's go see what our formula says. There's your x-axis. Okay, so everything's x's. So that's easy. We'll go from 0 to pi over 4. And so then we'll have cosine x squared dx. And so 0 to pi over 4. And this will be cosine squared dx. And I think I got my book here. Oh! Looking up the formula for it's the power reducing formula. I should have that memorized, but slipping my mind now. Double angle formulas. Let me see where that's at. So double angle. Give you some music. I'm looking at A42. Okay. Cosine squared. Let me write that over here. Cosine squared x is equal to 1 plus cosine 2x over 2. So, I'm going to replace this cosine squared here with 1 plus cosine 2x over 2 dx. Now that 2 I can bring out in front, so I got 1/2 pi, 0 to pi over 4, 1 plus cosine 2x dx. And Trying to think if we looked at ones like that. I don't think we look at that until next chapter, actually. But anyway, you can use this formula to rewrite it in this manner. Okay, now I'm going to split this up. So I'm going to have 0 to the power over 4 of 1 dx plus 0 to the power over 4 cosine 2x dx. Now this is a u substitution here, so we let u equal to 2x, du will be equal to 2 dx. This first one here, the integral of 1 is just x from this. And then this one, I'm going to put I need a 2 inside, so I'll put a 1/2 out in front. And then the integral of, then it would be cosine u, du. And the integral of cosine is sine. Because if we go backwards, the derivative of sine is cosine. So I'll have sine 2x. And this will be from this to this. Okay. So I got 1/2 pi. Sometimes when I start combining too many steps, I mess it up. The 0 doesn't do anything, so it drops away. So times pi over 4 plus 1/2. And I'll put in the pi over 4 there. So I got sine 2 times pi over 4 minus sine 2 times 0. 1/2 pi times pi over 4 plus 1/2. This is 2 pi over 4 or pi over 2, and sine is equal to 1 there, minus 2 times 0 is 0, sine of 0 is 0. So we got 1/2 pi times pi over 4. 1 minus 0 is 1 times half is half. Like that. I'll go ahead and multiply this through. This is pi over 2 times pi over 4 plus 1/2. That gives us pi squared over 8 plus pi over 4. Let's get a common denominator, which would be 8. So we've got pi squared over 8 plus, multiply top and bottom by 2 pi over 8, which gives us pi squared plus 2 pi over 8 is our answer. And assuming I didn't make a math error in some of this, we're all done. So let me save that. And bring up my recorder. Hour and 23 minutes. And F10.